Okay, this is a tutorial on solving systems of equations by graphing. This is an add-on to our lesson on solving systems of equation with elimination and substitution. So what I want to do real quick is just kind of refresh your memory about graphing lines. Remember, we have slope-intercept form is our most user-friendly way of graphing lines, where the M is your slope, which is defined as rise over run, and then your B, this number here, is the Y value of your y-intercept, and that's where the line crosses the y-axis, and that's a guaranteed point on your line. So we always start with that because we have to graph 2 points to be able to graph a line, and that y-intercept gives us one of those two immediately. So we're going to do that. So if you take a look at number 1 here, you'll see that 4 is our y-intercept for this first equation. So what I'm going to do is, again, keep you in mind that it's the y value of the y-intercept. So the reality is that the point is 0, 4. So I stay on the y-axis because I don't go left to right at all for my x value of 0, and then I go up 4. So again, that's one of the 2 points that I need to be able to graph this line. Now I use the slope to determine how I get from one point to the next point. Now the reason that lines are straight is because they have the same way to get from point to point to point to point throughout the entirety of the function, and that rise over run is what that slope is. So in this case right here, that M value is -3, or as we will say for the rise over run purposes, -3 over +1. So -3 means we're going to go down, because a negative rise would be down, and a +1 means that we're going to go right, because a positive run will be to the right. So down 1, down 2, down 3, and then right 1, and this would be our second point that we need to graph this line. Now keep in mind that a line is made of an infinite number of points, but we only need 2 of them to be able to graph that line. So I got my 2 points. I'm going to graph this as best I can. And there in red would be the first line of this system of equations. Keep it in mind that a system of equations is, and I'm going to change colors here. A system of equations is multiple lines, and the solution to that system is all the points that these two lines have in common. So I'm going to graph this next equation, focusing here where my, sorry, I got a little wild there. Focusing here that my -2 is my y-intercept, so that's going to be 0, -2, or down 2 on the y-axis. Now I only need one more point, so I'm going to use my slope, where my slope is 3, or 3 over run for rise over run. So positive and positive means I'm going to go up 3, 1, 2, 3, and right 1. Well, that's right there. So that is where the two lines are going to cross. That one point is what the two lines have in common, and thus will be the solution to the system. So the solution to this system will be indeed 1, 1. All right? Now we're going to do example 2, which has an interesting line, which is x equals -3. So it's not in our y equals mx plus b format because it's not a normal line. What this is saying is that no matter what the y value of this function is, the x values are all -3. So if I have a series of points that all have an x value of -3, and I'm just going to make several points that all have an x value of -3, so this is like -3, 0, -3, -1, -3, +1, -3, +5. So you can see this pattern starting to emerge as a vertical line. So whenever we see x equals a number, that's the indication that we're dealing with a vertical line. Notice that my slope or my rise over run does not include any running whatsoever. I'm not going left, I'm not going right. And that is what causes the problem for the slope-intercept form. So if I'm going up 1 every single time, but I'm not going right or left, that means that my run is 0, which means I'm dividing by 0. Well, that's undefined. Well, undefined isn't a number that shows up on our number line, which means we can't treat it normally like a normal slope. So that's why we have a completely different equation. So in green here, x equals -3 was a vertical line through -3. See if I could do a little bit better job with this line here. It's a little bit better. Okay, now I'm going to change colors back to that red and graph the other line in this system. Here we go. And it is in that slope-intercept form. So I can find my y-intercept, which is here. So 0, 2 is my y-intercept, and my slope shows up there. Well, that's an understood 1. So if my slope is 1, that would be 1 over 1. So now I'm going to use my y-intercept, which is 0, 2, and then I'm going to use my rise over run to get my next point. So up 1, right 1, and that will be my line. Now, just to make it real accurate, because I want these two lines to cross, and I want to cross at the exact spot that they have in common, I'm going to go backwards, down 1, left 1, down 1, left 1, down 1, left 1, and find that exact point that they have in common. So that point right there, which is -3, -1, will be the solution to this system. And I draw this line in here to graph and show the solution to the system. So to recap again, the solution to the system of equations is all the points that they have in common. This is the one point that they both have in common. And the first line, which is the one in red, we graphed using slope-intercept form, identifying the y-intercept and the slope. Then the second equation was a vertical line through -3. We recognize that because of the x equals format. Again, this says every single point on this function has an x value of -3.